We have to mention the cutting of the bugle, and every time we have to maintain this contact to nodal distance. The substrate to work to nodal distance, right? So, as you can see that in that case, along with the formations, there is some material flow, excess material flow is taking place. So that also creates an effect. Here, this is due to not being the proper center starting and the ending. If it is not being so, there is a chances of being the material flow. Right. So now we will again. This is the last year we are going to deposit this on bidirectional strategy. So here also strategy we have deposited of 5 layers. The last layer due to some continuous drag got not deposited, and there is a what we call delamination what takes place in the bidirectional strategy that you can see over here in this specific. This one is through the unidirectional strategy that we deposited earlier. These five layers are deposited through the bidirectional strategy. As I already mentioned and multiple times told you that every after time the globules the formation takes place, and due to this there is some material overflow is also taking place and some delamination is also being takes place. So it is due to the excessive heat accumulation, so it takes place. So we can in the similar fashion we can deposit. This was what? This was the single track multi-layer deposition. This was single layer multi-track deposition through bidirectional and through bidirectional strategy. Similarly, what we can do, we can go for the multi-track. So we can go for the uh, multi-track single wall direction, a single wall deposition, or multi-track multi-wall deposition. We can also go for that, and always we will see that the cooling rate will define the property of the component in which every part the heat, how heat is being accumulated throughout the part will leads to the will leads to the different microstructure and leads to the different properties in the different direction that will leads to the anisotropy of the material properties. So that we don't want. So in order to have the uniform property throughout the part, we need to be the very careful to the processing parameters, to the variables that we needed, to the deposition strategy, and as per the shielding gas that you are choosing. So these are the most important parameters that we can use. So now after the depositing the number of the beads, what we do initially, first we deposited single bead, then directly I have shown you that how the multi-wall being deposited. But in actuality, that does not take place. In actuality, what is done, initially single bead is being deposited, then as per design of experiment, number of runs are being done. On the every bead, the the optimization is performed. For what? That as I earlier mentioned, that what we need the higher lower dilution and higher reinforcement rate, reinforcement area throughout the bead. So for that, with the help of image software, we do the bead nomenclature of the area calculation, bead height, bead width, dilution. All these important parameters are being calculated, and then after that, with the help of the design expert software, we have to optimize, and that give an optimum value of the process parameter on which we can get the best deposition bead, and as per bead we define we deposit our complete part whose properties are as per the functionality and it can fulfill its function. So I think I have covered a lot of part in this session. In this session, if I just summarize, overall, we talk about the additive manufacturing, we talk about the classification of the additive manufacturing, then we talk the wire arc additive manufacturing, the types of the wire arc additive manufacturing, about the typical setup of the and the raw material that we are using in the form of the wire, the energy source. On the basis of the energy source, the classification of the wire arc additive manufacturing through GMAW, GTAW, plasma, and through the CNT, that is also the advanced version of the GMAW process. And after that, I told you about the CNC router, then controller, then this thermal energy source about the GMAW, then wire feeder, then gases, and how we can operate this CNC controller through NPG support, and then through the software basis part. And in the software basis part, it includes the programming part, G code, M code, all the things that I have described to all of you. So in that, also I have defined about the deposition strategy like unidirectional, bidirectional. Although these deposition can also take place through directly by combining a single program, but to avoid the any interruption and to avoid the formation of the globule, I discrete the program and just step by step I to make you understand I run that program. So 5 layers multi-wall I have deposited. So in the another session, next session, that Yaswant sir will take the from the further onwards, and he will tell you that I have told you about the how we selected the process parameter through the trial experiment, and through the trial experiment, the range that we got, that will be on the basis of the design expert or design of experimental setup. We will get the number of experimental run that we need to perform to get the optimized bead and optimize our build part to get the appropriate properties to fulfill its functionality. So how this design expert software will work, and how that with the help of the image software, the image processing will take place, how you will calculate the bead width, bead height, bead length, and the bead area, that will be will further on in the upcoming class from the 4:30 onwards. So thank you. Thanks a lot.
Now we'll be having a break for 20 to 30 minutes. Please keep connected or rejoin in the meantime.